Firstly, ensure the generator is running and capable of handling the combined load of both services. Secondly, at the service entrance, disconnect the neutral conductors from both services. Thirdly, on the load side of the services, connect the phase conductors A, B, and C in parallel. Ensure the phase rotations match. Fourthly, connect a bonding jumper between the neutral bus and the ground bus of the secondary side of the main distribution panel. Fifthly, disconnect the neutral conductors from all branch panels that are not being powered by the generator. Sixthly, verify that the voltage between the parallel phase conductors and the bonded neutral bus is balanced. It is important to note that the neutral bus must be bonded to ground to maintain a stable reference point for the electrical system. Disconnecting the branch panel neutrals prevents any backfeed from branch circuits onto the isolated neutral. The parallel services should be sized appropriately to handle the total load demand. Always consult with a licensed electrician for proper implementation and safety measures. Failure to follow proper safety precautions can result in serious injury or death. Ensure that all electrical connections are tight and secure. Only attempt this procedure if you have a clear understanding of the electrical system and the potential risks involved. The process of isolating the neutral in an electrical system during generator operation is critical to prevent backfeed and ensure safety. This involves several key steps that must be followed precisely. The initial step requires confirming that the generator set is fully operational and can manage the entire load of both electrical services. This ensures that when the utility power is disconnected, the generator can seamlessly take it over without overloading, maintaining continuous power for essential systems. Once the generator is confirmed to be running and capable, the next crucial step involves disconnecting the neutral conductors from both utility services at the service entrance. This disconnection is essential to isolate the utility's neutral from the internal electrical system of the building. By doing so, any potential for backfeed from the generator back to the utility through the neutral is eliminated. After isolating the utility neutral, the next phase focuses on paralleling the electrical services on the load side. This involves connecting the phase conductors, specifically phases A, B, and C, from both services in parallel. During this process, it's imperative to ensure that the phase rotations match correctly. Incorrect phase rotation can lead to significant electrical issues, including damage to equipment and potential safety hazards. Ensuring proper phase rotation is a fundamental step in paralleling electrical services safely and effectively. Following the paralleling of the services, establishing a secure bond between the neutral bus and the ground bus on the secondary side of the main distribution panel is essential. This bonding creates a stable reference point for the electrical system, which is particularly important when operating on generator power. A solid bond ensures that all components of the electrical system are referenced to the same ground potential, preventing voltage imbalances and reducing the risk of electrical shock. Further isolation is achieved by disconnecting the neutral conductors from all branch panels that are not intended to be powered by the generator. This step prevents any potential backfeed from branch circuits onto the isolated neutral, ensuring that only the intended circuits receive power from the generator. By selectively disconnecting neutrals, the system avoids unwanted current paths and maintains a clean and controlled power distribution. The final step involves verifying that the voltage between the paralleled phase conductors and the bonded neutral bus is balanced. Balanced voltage is an indicator that the system is operating correctly and that the load is evenly distributed across the phases. Voltage imbalances can indicate underlying issues with the connections or the generator itself. Regular voltage checks help maintain system integrity and prevent potential problems. Several important notes should be considered throughout this process. Firstly, the neutral bus must be securely bonded to ground to maintain a stable and safe electrical system. This grounding provides a reference point for all electrical potentials and helps protect against electrical shock. Secondly, disconnecting the branch panel neutrals is critical to preventing backfeed from branch circuits onto the isolated neutral, ensuring a clean separation between the generator-powered circuits and the rest of the electrical system. Thirdly, the parallel services must be adequately sized to handle the total load demand of the building. Overloading the system can lead to equipment failure and potential safety hazards. It's crucial to assess the total load and ensure that the generator and power load services can handle it safely. Always consult with a licensed electrician for proper implementation and to ensure that all safety measures are followed. Working with electrical systems requires expertise and adherence to safety protocols. Consulting a professional ensures that the installation is done correctly and that all potential risks are mitigated. Failure to follow proper safety precautions can result in serious injury or death. Electricity is a powerful force, and it's crucial to take all necessary precautions to protect oneself and others. Ensure that all electrical connections are tight and secure. Loose connections can cause overheating and arcing, which can lead to fires and electrical hazards. Regular inspections and maintenance of electrical connections are essential for maintaining a safe and reliable electrical system. Only attempt this procedure if you have a clear and comprehensive understanding of the electrical system and the potential risks involved. Working with electricity requires knowledge and training. If you're not comfortable with any part of the process, it's best to consult a qualified electrician. The specific tools and equipment needed for this procedure will vary depending on the size and complexity of the electrical system. However, some common tools include insulated screwdrivers, voltage testers, wire strippers, and a multimeter. Ensure that all tools are in good working condition and that you are familiar with their proper use. Before starting any electrical work, it's crucial to energize the circuit or equipment you'll be working on. This can be done by turning off the appropriate circuit breaker or disconnecting the power supply. Always verify that the circuit is de-energized using a voltage tester before proceeding. Wear appropriate personal protective equipment, or PPE, such as insulated gloves and safety glasses. PPE helps protect against electrical shock and other hazards. Regular inspections of PPE are essential to ensure that it's in good working condition. Follow all applicable electrical codes and regulations. The electrical codes are designed to ensure the safety and reliability of electrical systems. Familiarize yourself with the relevant codes and regulations before starting any electrical work. Keep a clear and organized workspace. A cluttered workspace can increase the risk of accidents. Keep all tools and materials in their proper place and ensure that the work area is well lit. Be aware of your surroundings. Pay attention to potential hazards such as wet surfaces, exposed wires, and other electrical equipment. Avoid distractions and focus on the task at hand. If you're unsure about any aspect of the procedure, stop and ask for help. It's always better to be safe than sorry. Consulting with a qualified electrician can help clarify any uncertainties and ensure that the work is done correctly. Regularly inspect and maintain the electrical system. Regular inspections can help identify potential problems before they become serious. Maintenance tasks such as tightening connections and replacing worn parts can help keep the system running smoothly and safely. Keep accurate records of all electrical work. Accurate records can be helpful for troubleshooting problems and for planning future maintenance. Include details such as the date of the work, the nature of the work, and any parts that were replaced. By following these steps and precautions, you can safely isolate the neutral and operated generator in conjunction with power load services. Remember, electrical work can be dangerous, so always prioritize safety and consult with a qualified professional if you have any questions or concerns. The information provided here is for informational purposes only and should not be considered a substitute for professional advice. Always consult with a qualified electrician before performing any electrical work. Ignoring safety precautions can lead to serious injury or death. Be mindful of the specific requirements and regulations in your area. Electrical codes and regulations can vary from place to place, so it's essential to be aware of the local requirements. Obtain all necessary permits and approvals before starting any electrical work. Permits and approvals are often required for electrical work to ensure that it meets safety standards. Contact your local building department to determine the specific requirements in your area. Consider using a qualified electrical inspector to inspect the work after it's completed. An electrical inspector can verify that the work was done correctly and that it meets all applicable codes and regulations. This can provide added peace of mind and help ensure the safety of the electrical system. Document the entire process with photographs and videos. Documentation can be helpful for troubleshooting problems and for providing evidence of compliance with codes and regulations. Keep the documentation in a safe place and make it accessible to qualified personnel. Develop a written plan for the procedure. A written plan can help ensure that all steps are followed correctly and that all necessary precautions are taken. The plan should include details such as the tools and equipment needed, the sequence of steps, and the safety precautions to be followed. Review the plan with all personnel involved in the procedure. A thorough review of the plan can help ensure that everyone understands their roles and responsibilities. It can also help identify any potential problems or concerns before the work begins. Conduct a pre-job safety meeting. A pre-job safety meeting is an opportunity to discuss the potential hazards involved in the procedure and to review the safety precautions to be followed. All personnel involved in the procedure should attend the meeting. Ensure that all personnel are properly trained and qualified to perform the work. Electrical work should only be performed by qualified personnel who have the necessary training and experience. Provide ongoing training to personnel to keep them up to date on the latest codes, regulations, and safety practices. Implement a lockout/tag-up procedure. A lockout/tag-up procedure is used to prevent accidental energization of electrical equipment during maintenance or repair. The procedure involves disconnecting the power supply and placing a lock and tag on the disconnect switch to prevent it from being turned on. Regularly audit the electrical system to ensure that it's in compliance with codes and regulations. An audit can help identify any potential problems or deficiencies. Implement a corrective action plan to address any problems or deficiencies identified during the audit. Keep up to date on the latest electrical codes, regulations, and safety practices. The electrical industry is constantly evolving, so it's essential to stay informed about the latest changes. Attend training courses, read industry publications, and network with other electrical professionals to stay up to date. Share your knowledge and experience with others. By sharing your knowledge and experience, you can help others stay safe and improve their skills. Participate in industry events and contribute to online forums and discussions. Strive for continuous improvement in electrical safety. Electrical safety is an ongoing process. By continuously seeking ways to improve safety practices and procedures, you can help prevent accidents and injuries. Foster a culture of safety in the workplace. A culture of safety is one in which everyone is committed to safety and takes responsibility for their own safety and the safety of others. Encourage employees to report hazards and to speak up if they have any concerns about safety. Lead by example. As a leader, it's important to demonstrate a commitment to safety by following all safety rules and procedures. This will help create a culture of safety in the workplace. Remember, safety is everyone's responsibility. By working together, we can create a safe and healthy work environment for everyone.